Seismic events are the most devastating of all natural disasters, leading to the highest fatalities and significant financial losses. Due to the destructive impact of earthquakes, the necessity for designing structures that can withstand seismic forces became apparent, prompting the initiation of research in engineering seismology at CWPRS. Consequently, the Engineering Seismology Division at CWPRS was established in 1963. This division has been actively engaged in providing project-specific consultancy services in the fields of seismology and earthquake engineering. Engineering Seismology Division has been conducting studies in the following areas. 1. Estimation of site-specific seismic design parameters. 2. Micro-earthquake studies. 3. Strong motion studies. 4. RIS, Reservoir Induced Seismicity studies. 5. Microtremor studies. The site-specific seismic design parameter studies are carried out for obtaining design response spectra, design acceleration time histories, and seismic coefficients. Design response spectra. A standardized curve obtained from the site-specific seismic hazard assessment that defines the expected maximum response acceleration, velocity, or displacement of structures for design purposes under a given seismic hazard. Design acceleration time histories. Synthetic acceleration time series adjusted to be compatible with the design response spectra, used for dynamic analysis of structures. Seismic coefficients. Dimensionless factors that represent the expected level of ground shaking or seismic forces, used in simplified design methods to estimate lateral loads on structures. The peak ground acceleration, PGA, values at a site of interest can be estimated using two approaches, namely deterministic and probabilistic methods. CWPRS has conducted more than 120 site-specific seismic design parameter studies in India, and also for our neighboring countries like Bhutan, Afghanistan, Myanmar, and Nepal. CWPRS has recently completed a study on the seismic hazard assessment for North and Northeast India under the Dam Rehabilitation and Improvement Program, DRIP. Following this, a software tool was created to calculate the target response spectra, design response spectra, and acceleration time history for any location above 24.5 degrees north, based on the results of the study. Micro-earthquake studies are helpful for determining the local seismicity and identifying any active faults in the vicinity of a project site. Seismic parameters, including source radius, seismic moment, stress drop, and moment magnitude, are calculated from the examination of micro-earthquake data. For undertaking micro-earthquake studies, CWPRS is equipped with various instruments, including 3-component short-period and broadband velocity sensors. CWPRS has conducted various micro-earthquake studies in India and also in neighboring countries like Bhutan and Nepal. A network of more than 6 seismological stations is required for finding the seismic potential of a project area. CWPRS also has its own seismological observatory located within its campus. The recording and analysis of strong motion accelegraph SMA data provides a useful basis to study the ground motion characteristics of engineering importance and to estimate the seismic source parameters. The SMA data are also used for simulation of design ground motion for a project site. Strong motion parameters used for design purposes are peak ground acceleration, peak ground velocity, peak ground displacement, Arias intensity, duration of strong motion, and cumulative absolute velocity. For undertaking strong motion studies, CWPRS is equipped with various types of accelerographs. Reservoir Induced Seismicity (RIS) studies are carried out to assess the seismic activity resulting from reservoir impoundment, to estimate the potential RIS magnitude, to monitor and analyze changes in local stress and pore pressure conditions after reservoir filling. To evaluate the seismic safety of dams and nearby structures, various characteristics of the reservoir such as its depth, storage capacity, in situ stress field in the reservoir area, activity of nearby faults, and dominant geological and rock characteristics are considered in RIS studies. Microtremor studies. Studies are carried out to determine the predominant, fundamental frequency and amplification characteristics of soil at a site. To classify site conditions based on shear wave velocity and resonance behavior. To assess local site effects and potential amplification of seismic waves.